Let's find the distance between points P and Q. P is 4, 2. Q is -2, -6. Do this in two ways. First, using the distance formula. So my points are x1, y1, x2, y2. First xy, second xy. So the distance formula says, let's say x2 minus x1 squared plus y2 minus y1 squared. Take the square root of all of that. That's the distance between those 2 points. So x2 is -2 minus 4 squared plus y2, which is -6, minus 2 squared. -2 minus 4 is -6 squared plus -6 minus 2 is -8 squared. Distance equals the square root of -6 squared is 36. -8 squared is 64. The distance between those 2 points is the square root of 100, positive square root of 100, which is 10 units. I can do this on a graph as well. Plot point P, that's 4, 2. There's point P. Point Q is -2, -6. There's point Q. I want to find the distance between those 2 points, or the length of the segment. Oh gosh, this is bad. The length of the segment that joins those 2 points. This segment here. The length of that segment. I can create the triangle, the right triangle around those 2 points here. There. Alright, smart angle. This segment here, this leg, 1, 2, 3, 4, 5, 6. This leg, 1, 2, and plus that 6 there, that's 8. If you remember your Pythagorean triples, right triangle, the legs are 6 and 8, the hypotenuse must be 10. Or you can use the Pythagorean theorem, where C is the length of the hypotenuse, the side that we're looking for always. Let's say A is 6 squared, plus B is 8 squared, equals C squared. 36 plus 64 equals C squared. You can see it mirrors here. 100 equals C squared. So if I want to find C, I'm taking the square root of both sides. I want the positive square root because we're talking about distance. So 10 equals C. Either way, you'll get the distance between those 2 points, or the length of the segment that joins those 2 points, as 10.